Welcome to the third and final part of the blog platform builder project. If you haven't seen the first two parts yet, then you'll need to do those first. There is links in the description below for those. If you've done parts 1 and 2, in this part you can look forward to adding the JWT authentication filter, implementing the tag endpoints, implementing the post endpoints, and of course, wrapping up the project. As a reminder, if you want the lesson write-ups, the project source code, or to ask the community a question, then be sure to join the Devtiro community site. You can join for free, link in the description below. So then, let's get started. In this lesson, we build on our authentication implementation from previous lessons. We'll now create a filter to validate JWTs on our protected endpoints. This filter enables stateless authentication by validating tokens and establishing the user context for each request. So here we are back in our IDE. Now let's go over to our authentication service and let's expand this. So at the moment, we're able to authenticate a user. We're able to generate a token. Let's add an additional method to this service. It will return user details and we'll call this one validate token. And it will take a string token, which will be the value of our JWT. So authenticate takes the email and password, authenticates the user, returns their user details. Generate token will turn the user details into a JWT, and this one will turn the JWT into user details. So let's go down to the authentication service, hover over, go to implement methods, implement, and now we have the validate token method stub to implement. So our first challenge is to extract the username from the token. So to do that, I'm going to create a new private method. Private, it will return a string, which will be the username, and we'll call this one extract username. And it will take the token string as an argument. And we're going to say JWTS dot parser builder. We'll set the signing key. And again, we'll call the get signing key method that we've created down here. We'll call build. And then we can call pass claims, passing in our token. And then we'll call get body. And that will return a claims object, which will assign to a variable called claims. Let's import claims. Okay. And now we can call claims dot get subject and return this. And that will return the username, remembering that we put the username into the subject up here. Now, it should be noted that an exception will be thrown if the, for example, signing key doesn't match. So we only return a username if it is a valid JWT. So we can now use our extract username up here in our validate token method. So we'll say string username equals extract username, passing in the token. And then we'll go return user details service dot load user by username, passing in the username. Of course, we could also process some additional claims at this point. However, we're not using any additional claims in this implementation, at least not in this iteration. So in this way, we're able to pass the token, relying on the JWTS object here to do all of the heavy lifting. So all of the complexity is dealt with in this builder pattern here. And then we extract the subject, which is the username, and we only get that if it is a valid JWT. And then we're able to use our user detail service to load the user by username, passing in the username. And that should do it for our validate token method. So now that we have this method, we can use it in a custom filter. So let's go up to project here. Let's go to our security package and let's create a new class. And we'll call this one JWT authentication filter. And let's expand this. Now this class is going to extend the once per request filter because of course we only want this to run once per request. So we hover over this, go to implement methods, go OK. And let's put these on some new lines. We now have this do filter internal method to implement. So to implement this method, we're going to need the authentication service. So let's put the required R's constructor on the top here. And now we'll say private final authentication service. And we'll call this one authentication service. And now it's available to use in our class. So inside of the do filter internal method, the first thing that we'll want to do is to extract the token. So we have that to pass in to our authentication service. And for that, I think we'll do a private method. So private string, and we'll call this one extract token. That will take the HTTP servlet request, which we'll call request. And the first thing that we'll do is try and extract the authorization header. So request.getHeader and its authorization. And we'll assign that to a string, which we'll call bearer token. Remembering that a JWT will be provided in the request prefixed with the word bearer. So we'll now need to split that out so we only have the token value. So we'll say if bearer token does not equal null, we'll say bearer token dot starts with bearer space. So if the bearer token is not null and starts with the word bearer, then we're going to return the bearer token dot. We'll use substring for this, starting at index 7. Of course, you can make this implementation as refined as you like. This is a very simple implementation, but should do what we need it to at the moment. Now, if we find that the bearer token is null or doesn't start with the word bearer, then we're going to simply return null in this case. So we can now use this extract token method up here. So we'll say string, and we'll call this one token, extract token, passing in the request. So we'll now say if the token does not equal null, then we can look to validate the token. So we'll say user details, and to this variable, we'll go authentication service dot validate token, passing in the token that we've just extracted. And providing it was a valid JWT and the credentials are valid, then we can go about creating a new username, password, authentication token. So this is our authentication object. And to that, we'll need to pass in our user details. For credentials, we'll just pass in null. And for authorities, say user details, get authorities. We'll assign this to a variable called username, password, authentication token. And we'll call this one authentication as it represents our authentication object. And now we can go about setting this on our security context. So let's do security context holder dot get context dot set authentication, and then we can set the authentication object on the security context. And that makes that authentication object available for the rest of the request, essentially setting the authenticated user. Now, something which can be handy later on is we'll set the user ID. Rather than having to look up the user by the email address each time, we can simply just use the user ID. So if we say if user details, instance of, and I like to use this sparingly, but I think this is a good case for it, instance of blog user details, then we'll say request dot set attribute, and we'll call this attribute user ID. We'll cast our user details to blog user details, and then we'll call on that get ID, which doesn't yet exist on blog user details. So let's create the method in blog user details, remembering our ID is a UUID, and we can return user dot get ID. If we go back to our JWT authentication filter, we now have our user ID, UUID type, set as an attribute user ID, which we can access throughout the request. So at the moment, exceptions are going to bubble up. And that means we are going to get exceptions returned if there is, say, an invalid JWT. Because we're in a filter here, we simply choose to not authenticate the user rather than return an exception each time. And then we can rely on the rest of the application to do what it needs to do when there is no authenticated user. So what we'll do then is we're going to wrap all of this in a try, and we'll say catch exception EX, and we're simply going to say in a comment, do not throw exceptions, just don't authenticate the user. And it's good practice to put a log line in rather than just duck an exception like this. So we're going to add the self4j annotation to the top here, which makes the log variable available. And we'll put a warn message in here, which says received invalid auth token. And at least we're aware when there's invalid auth tokens being passed into the system. And then the last thing that we need to do on our filter is call filter chain, dot, do filter, request, response. So that's the first iteration of our JWT authentication filter done. Now let's look to use it. Now that we've implemented our JWT authentication filter, in this lesson, we'll look to use that filter and log in with a user. So let's open up our project here, go over to our config, security config, and let's expand this. And let's scroll down. So the first thing that we should do is inside of our request matches, let's add another line. And now that we have new endpoints to do authentication, let's put in auth in here. And we'll say any post request to v1 auth is permitted because we're using this endpoint in order to log in. And with that done, we can now configure our filter. So let's create a bean for our filter. So we'll go @bean, public, JWT authentication filter. We'll call that method JWT authentication filter also. And then we'll return a new JWT authentication filter. And as for the arguments, it requires the authentication service. So we'll pass that in as an argument up here, authentication service, like so. And we now have our JWT authentication filter bean available. We'll add a second argument to this method, which is going to be our JWT authentication filter. And Spring will know to inject that because we've declared the bean just up above. And now on the last method here, we can call dot add filter before JWT authentication filter, and we'll add this before the username password authentication filter dot class. And with that, we should have everything that we need in order to have some working authentication in our system. Now, quick disclaimer, it should be mentioned, this is a very basic implementation and you'll want to do a whole lot more in a proper production system. However, this should give us the bare minimum. So if we click on refresh up here to start or restart our application, we can see that we're missing a bean of user detail service in our configuration here. So let's pull that down and we'll declare a new bean. Say public user detail service, and we'll return a new blog user detail service, which requires the user repository. So we'll say user repository, and then we'll pass that in like so. And that makes the user detail service bean available for our application. So let's try once more. And that's our application started up successfully. So let's try this out. Let's start with Postman and then work our way over to the front end. So here we are back in Postman. Now at the moment, we don't have any users in our application. So let's see what happens when we try and authenticate when the user's credentials aren't valid, purely because the user doesn't exist. So here we have the email for user@test.com. Again, just a dummy value. And the password we've set here to be password123!! Again, not a strong password, but we're just testing. So we're going to send this to API v1 auth on a post. Okay, so we get a 401 unauthorized. So we can see here, incorrect username or password. Perfect, exactly what we expect. So next, we'll create a user and then log in with that user. Now, there are various different ways that we can create users in our system. Of course, we can build out a full user management part of our application. But in order to keep things simple, we're going to simply create a user when we start up our application, and that will be the user that we use for our blog. Of course, feel free to build this out as far as you would like. But for the moment, we're going to go to security config here. Let's expand this. And here we have our user detail service bean declaration. So rather than just return our blog user detail service, I'm going to assign that to a variable, blog user detail service. There we go. And we can return that at the end here. And now we can look to create the user if they don't exist. Again, this isn't something you want to do in a production system. You want to build out that full user management functionality. But for us, it should work perfectly fine for the moment. So we're going to use the user repository that's been passed in as an argument up here. And we're going to say find by email. And we're going to use the same email of the user that we've just tried out in Postman. And that was, let's assign that to a variable, string email. And that was user@test.com. Again, just a dummy value. And let's pass it into find by email. Now this will return an optional. So we only want to create the user if they don't already exist. So we'll then say or else get, and then we'll go about creating our user. So we'll say user, making sure we import from our domain .builder.build. Assign this to a variable which is called new user. So we'll not set an ID. We'll not set any posts. Let's set a name. We'll say test user. Set an email, which is going to be that email address there. We need to set a password, of course. And for that, we'll need to use our password encoder.encode. And we'll just have the string password as the password. And we just remind ourselves what's on user. We're setting the email, setting the password, we've set the name. Post will default to a new array list. Created that will be populated for us. So that's all we'll need to do. So what we'll do then is say user repository dot save, and we'll save our new user, returning that at the end of the Lambda. And in this way, we're just going to create a test user that we can use if that user doesn't already exist in the database. So let's try restarting our application here. Okay, it looks like our application is started up fine. So let's head back over to Postman. Let's just send this same request that we sent a moment ago and see if we are able to log in. We're getting a HTTP 401, but that's because I set the password as password, not password 123. So let's try once more. Wonderful stuff. So we now get a HTTP 200 and we get a token value here, and we've got an expires in value as well. So it looks like our authentication endpoint is working as expected. So let's now try this out in our front end. So here we are in our front end. So let's head over to the login page here. Let's just pull this down a little bit and let's try logging in. So user@test.com, and the password for this one was password. And if we click on sign in, we get a HTTP 500, which is unexpected. So let's take a look at this and see why. Post 500, let's take a look at the response. An unexpected error occurred. Okay, our front end is displaying the error because it's in the standardized format, but it seems like we are getting a 500. That's not a lot to go on. So if we take a look at this request, we can see that the payload is sending the email and the password correctly. That's all correctly formed. We are using HTTP post, but it appears I've made a mistake on the URL here. So the front end, as we initially designed, is using v1 auth login. Whereas if we go back to our IDE, we've implemented API v1 auth. So it should be /login. And because we've changed the URL here, we'll need to go over to our security config. Let's just minimize that actually. Maximize that. And we'll scroll to our security filter chain and change that also to be login, allowing calls to the login endpoint. So if we restart our backend now, okay, so that's our backend restarted. Let's head back to our front end. And if we try logging in once more, fantastic. So it looks like the login was a success. Let's just track down that call, login 200. Great. So here's our login, HTTP 200, v1 auth login. And here's our email and here's our password. So it looks like we have now successfully logged in, which means we get access to the drafts post page. We can create a new post. We can do everything a logged in user can do. Now, if we go ahead and log out for a moment, let's just bring the networks panel back actually. Just before we move on, let's just make sure that we can't log in with just any username and password. So let's go user@test.com because we know that to be a valid user. And let's just put some random characters in the password. And now let's try signing in. Okay, great. So we get a 401 on the response there. Great. So it looks like our authentication implementation is now working as expected. In our previous lessons, we implemented user authentication and security for our blog platform. In this lesson, we'll create an endpoint to list all of the tags and their associated post counts. So here we are back in our IDE. Now we're going to use a dedicated DTO for our tag data. So inside of domain, DTOs, we're going to create a new Java class, and this one's going to be called tag response. Let's expand this. Now as a DTO, we can make full use of Lombok. So at data, all args constructor, no args constructor, and we'll put builder on there as well. Now we can add our instance variables, so the things we want to know about our tag. So the first one is going to be the ID, which is a UUID type, and we'll call that instance variable ID. I also want to know the name of the type. So we'll do an instance variable string type name. And I also want to know the post count. So how many posts are associated with this tag? And for that, we'll say private integer, and we'll call that one post count. And that should do it for our tag response DTO. Of course, we are going to have to configure our mapper to go from a tag entity to a tag response DTO. So let's go there next into our mappers package here, and we'll create a new Java class, and we'll call this one tag mapper. And we'll make that an interface, and let's expand this. So just like for our categories, we're going to put the mapper annotation on the top here. The component model for this one is Spring, unmapped target policy, reporting policy.ignore. So exactly the same as on the category mapper. Now let's add a method here, which is going to return a tag response. And we'll call this one to tag response. And it will take a tag, which we'll just need to import from our entities. Okay. Now, very similar to categories here, we're going to say mapping. And the target of this mapping is going to be the post count instance variable. Source equals posts, qualified by name, and we'll say calculate post count. And this is a method that we are just about to create. So we'll say default. This will return an integer called calculate post count, and it will take a list of posts, which we'll call posts. Import list. There we go. Now to the top of this method, I'm going to use the named map struct annotation here, and then call it calculate post count to make sure it matches up here. And now we can go about implementing this method. So first things first, we'll say if posts is null, then we'll simply return 0. Otherwise, we'll say posts.stream, and then we're going to filter out to get only the posts that are published. So we'll say post status dot published equals post dot get status. Let's put that on a new line. And then we simply want the count, which returns a long. We want an integer. So we're going to return, we'll just cast that to int there. There we go. And that should be enough in order to populate the post count instance variable with the count of the posts associated with that tag. So now that we have our DTO available and a mapper to map it, let's now create that controller. So let's go to the controllers package here. We'll create a new Java class, and we'll call this one tag controller. And let's expand this. This, of course, is going to be a REST controller. The request mapping for this one is going to have the path of /API v1 tags, and we'll put a required R's constructor on there as well. So now for our endpoint. So this one's going to be a public method returning a response entity with the value of a list of tag responses. Let's import list. And we'll call this one get all tags. And let's put a get mapping on the top of this because it's going to use the HTTP verb get all tags. Now we're going to need a way to list the tags that we have in the system. So we're going to need a tag service. So let's go ahead and create the tag service in our service layer. So services, new Java class, tag service, and this one's going to be an interface. And let's expand that. Now tag service only needs a single method. It's going to return a list of tags, and we'll call this one get tags. Let's import tag. Let's import list as well. Great. So now that we have our tag service interface, let's go ahead and implement it. So in our import directory, we'll create a new Java class, and we'll call this one tag service import. And let's expand this. So tag service import, of course, implements our tag service. Before we go any further, let's add the service annotation to the top so we don't forget. Let's hover over this red squiggle. Implement methods, get tags. Great. So we just need to implement our get tags method now. The easiest way to do that is to use the tag repository. So if we add a required R's constructor to the top of the class here, private, final, tag repository, we'll call that tag repository. Great. So we now have our tag repository. We can use it in our implementation. Now we could do tag repository.findAll, but that's not the most optimal way of doing things for the same reason as for categories. So let's just double check our tag repository. Okay, yes, so let's add a new method here, very similar to how we had on the categories repository. There we go. So we just created a method called find all with post count. We're specifying a query here, and it will do a left join with post. So this will include all of the posts that we need to do our post count. Rather than relying on Hibernate to go one by one and doing several queries, we're doing it in one query here. So if we go back to our tag service import, we can now use tag repository dot find all with post count to return our list of tags, which means in turn, back in our tag controller, we can now import our tag service, private final tag service, which we'll call tag service. And let's also declare an instance variable for our tag mapper. And we have everything we need to implement our get all tags endpoint. So first, let's call tag service dot get tags, and that will return a list of tags. So let's assign that to a variable called tags. Now we'll convert this to a list of tag responses. So we'll go tags dot stream dot map, and we'll say tag mapper dot to tag response, passing in our tag. And let's just optimize on that. And let's assign this to a list tag response. We'll call this one tag responses. And of course, we'll go to list to get our list type. And now we have a list of tag responses to return. So we'll say return response entity dot OK, passing in our tag responses. And with that, we've implemented our list tags endpoint. So let's restart our application and try it out. So we have an error here, and it's to do with the type of the collection. So rather than a list of posts, it should be a set of posts. And the reason being, of course, is that the tag entity has an instance variable set of posts. So with that change, let's try again. There we go. It looks like the application started up fine. So let's head over to Postman first. So here we are in Postman. So this endpoint should be open. It doesn't have any authentication associated with it. So if we hit this, get API v1 tags, let's see what we get. Okay, great. We get a empty array, which is all we can expect at the moment because we haven't implemented the create tag endpoint. Let's just see this also working in the front end. So here we are in our front end, and we can see the calls to get API v1 tags are returning a 200 OK with an empty array. So everything looks to be working for our list tags endpoint. Building on the list tag endpoint from the previous lesson, we'll now implement the create tag endpoint. So here we are back in our IDE. The create tags endpoint is going to require a DTO. And that DTO is going to represent the tags to create, because we're going to support the ability to create more than one tag at a time. So over in our domain package in DTOs, we're going to create a new Java class, and we're going to call this one create tags request. And let's expand this. So as a DTO, we're going to use @data, all R's constructor, no R's constructor, and builder as well. And for the instance variables, we'll say private set of string, and we'll call this one names. And this will be the names of the tags to create. However, just like we did with categories, let's now add some validation annotations as well. We want to make sure that at least one name is provided. So we'll add the not empty annotation here with the message at least one tag name is required. We also want to make sure that not too many tags is provided. So we're going to set a maximum of 10 tags in this request. We can do that with the @size annotation. And as for the actual tag names themselves, let's add two annotations. So an @size annotation to say they should be between 2 and 30 characters, and an @pattern annotation, which specifies that the tag names can only contain letters, numbers, spaces, and hyphens. We don't want any special characters making their way into our tag names. So to do that, inside of the set declaration here, put in these two annotations, one for @size and the other one for @pattern, which we'll need to import. Again, you'll find these annotations in the lesson notes. So we can see here @size, minimum of 2, maximum of 30 characters, and then a regex pattern here, which specifies that the tag name can only contain letters, numbers, spaces, and hyphens. And with that, we have our create tags request. So now that we have our create tags request DTO, let's head over to our controller. So let's go to tag controller and we'll add a second endpoint here. This one is going to be a post mapping, public, turning a response entity, which is going to be a list of tag response. And we'll call this method create tags. And of course, it will take a request body, which is going to be a create tag request, the other DTO we just created. And we'll call that one create tags request. Now, in order to create tags, we're going to need to add a new method to our tag service. So let's head over to our tag service and let's add a second method here. This one will return a list of tag, so the tags that have been created. And we'll call this one create tags. And it will accept a set of string, and that's going to be the tag names to create. Let's import set. Great stuff. So let's head over to the implementation. Let's hover over here, go implement methods, click OK. And now we can implement create tags. So we only want to create new tags in the database. So let's check the database first to see if any tags exist rather than try and create them again. So let's head over to our tag repository here and let's add a new method to this one. This will return a list of tag and we'll call this one find by name in. And to that we'll pass a set of string, which is going to be the names of the tags. Let's import set here, a semicolon at the end. So to this method, we'll pass a set of names, and then the tag repository is going to return all of the tags with the names matching the names that we've passed in. So if we go back to our tag service import now, let's call tag repository dot find by name in, and then we'll pass our tag names to that method. And we'll assign this to a variable, which we'll call existing tags. So we only have the tag names to work with as arguments passed into this method. So let's now extract the tag names from existing tags. We'll say existing tags dot stream dot map, and we'll say tag dot get name. Let's just optimize on that. And we'll collect this into a set. We'll assign this to a variable, and we'll call this one existing tag names. Great, let's put this on some new lines. Okay, so now we have a list of existing tag names. So what we'll do now is we'll filter the tag names passed in, so we only have a set of names of new tags to create. So let's do tag names dot stream dot filter, and we'll say the name, and then we'll say existing tag names dot contains the name, but of course we want it to be, it does not contain the name. Let's put that on a new line. So at this point, we have a stream of tag names that aren't already in the database. So let's go and convert those into tags. So let's map on that. Let's call that name. And let's use our tag builder. So we'll say tag dot builder. And we'll say the name is the name. The posts will be a new hash set. As it's a brand new tag, it won't yet have any posts associated with it. Let's call build. And finally, let's collect. But this time we'll collect into a list. Let's assign this to a variable, which we'll call new tags. And I think we can optimize on that. Great. So we now have our list of tags to create. So these are brand new tags. These don't yet exist in the database. So let's now save our new tags. So let's check first that new tags is not empty. And if it's not empty, let's call the tag repository dot save all, and we'll pass in our new tags. Let's create a variable up here, which will be a list of tag, which we'll call saved tags, which is assign a new array list to that initially. And that way, we'll have our saved tags assigned. And now we can return all of the tags. So we'll combine the existing tags with the saved tags. So let's say save tags, add all existing tags, and then we'll return our save tags. There we go. And of course, we've made multiple calls to the database in this method. So let's add the @transactional annotation to the top of the method there. And that will make sure that all of these calls to the database happen within the same transaction. So with that implemented then, let's head back to our tag controller and let's look to use our new method. So let's say tag service dot create tags. and we'll pass in create tag requests dot get names, and we'll assign this to a variable, which we'll call saved tags. And now we'll convert our saved tags into tag responses. So we'll say save tags dot map, then we'll say tag, and then we'll call our tag mapper dot to tag response, passing in our tag, and then we'll collect this into a list. We'll assign this to a variable, which we'll call created tag responses. Let's optimize on this while we're here. And we can now return a new response entity, passing in our created tag responses, and we'll return the HTTP status of created. Semicolon there. And with that, we should have a fully implemented create tags endpoint. So let's try it out. Let's start or restart our backend. Okay, that's our backend started up fine. Let's now head over to our front end. So here we are in our front end. Let's go ahead and log in. User@test.com. Password, to which we have no tags listed here. So let's add some tags. So let's go with foo, bar, baz. Let's just clear down our networks panel and then let's click on add tags. Okay, great stuff. Let's take a look at this. Let's pull this up. So we can see here we've made a post to API v1 tags and we have a 201 created. The payload looks good. Names and array foo bar baz, so that matches our DTO. And in our response, we have a list of tag objects, each with an ID, the name, and then the post count of 0 associated with them because they're brand new tags. Wonderful stuff. Let's just pull this down. And it looks like the tags are correctly being displayed on the tags page as well. Wrapping up the tag management functionality will now implement the ability to delete tags. This endpoint will enable content organizers to remove unused tags while preventing the deletion of tags that are still associated with posts. So here we are back in our IDE. Now we'll not need to create any DTOs for this, so we're going to head straight to the tag controller here. Let's scroll down to the bottom, expand this, and let's add a new endpoint. So this one is going to be a delete mapping, and the path for this one is going to specify the ID. So we'll specify the ID in the path like so. It's a public method returning a response entity of void type, and we'll call this one delete tag. And we'll add the path variable annotation for the UUID ID. So with that done, we'll now need to add a new method to our tag service to be able to delete a tag. So let's scroll up here, go to the tag service, and let's add a new method, returns void, which we'll call delete tag, and it takes a UUID, which we'll call ID. So with that done, let's now go to the implementation of tag service, hover over here, go to implement methods, okay. And now we have our delete tag stub, which we can now implement. So we'll need to check that the tag isn't associated with any posts. So we'll need to retrieve it from the database in the first instance. So let's say tag repository dot find by ID, passing in the ID. We'll then say if present, giving that the name of tag. We'll check if tag.posts, so get posts, dot size is greater than 0. Let's just put that in an if. And we can optimize on this actually. So we can use is empty. So if post is not empty, then we're going to throw a new illegal state exception. And we'll say cannot delete tag with posts. However, if get post is empty, then we can go ahead and delete it. So let's say tag repository dot delete by ID, passing in the ID. There we go. And we'll need to put the @transactional annotation on the top here because we're making multiple calls to the database. And here we are. So we look up the tag in the database using find by ID. If it exists, then we check to see if it has any posts associated with it. If it does, we'll throw an illegal state exception. However, if it doesn't, then we'll go ahead and delete that tag. Now you might be wondering why we're using if present here. Well, quite simply, if we go to look up the tag in the database and we find it doesn't exist, then by definition, delete tag has done its work. There is no tag in the database with that ID. So you could call that a success case. So we're not going to throw an exception for that. So now that we have our delete tag method, let's head back to our tag controller. Let's scroll down here. And now we'll call tag service dot delete tag, passing in the ID there. And then we'll return response entity dot no content. We need to call build on that. There we go. So like that, we've deleted our delete tag endpoint. So if we now restart our application, there we go. So that's restarted successfully. We can now head over to our front end and try this endpoint out. So here we are back in our front end and we're on the tags page here. And we've got foo, bar, and baz that we created just a moment ago. So if we clear down our network panel, let's try out the delete endpoint. So let's delete baz at the end here and click on OK. Okay, so we only have two in the list now, foo and bar. So let's take a look at the request here. Let's pull that up. Great. So we've got a delete request being made to API v1 tags with the ID of the baz tag. And we have a 204 no content as the response. And the next call, which is to list the tags, we take a look at the response there. We only see two, foo and bar, and they are the same tags that we have listed in the front end here. So it looks like our delete tag endpoint is working as expected. Building on our tag management implementation from previous lessons, we'll now create a flexible endpoint for retrieving blog posts. This endpoint will support filtering by categories and tags, whilst ensuring only published content is accessible to users. So here we are back in our IDE. So let's go into our controllers package, create a new Java class, and we'll call this one Post Controller. And let's expand this. And to the top of this class, we're going to add the REST controller annotation. We'll add a request mapping annotation also, and we'll specify the path of /API v1 posts. And we'll also add the required args constructor as well, as we've been using that throughout. And now we'll specify our endpoint. So we'll say get mapping, public, returning a response entity, which will return a list of, and now we need to create our post DTO class. So let's open up our project here. And inside of DTOs here, we'll create a new Java class, and we'll call this one Post DTO. Let's expand this. So to the top of the Post DTO class, we're going to add @data, all args constructor, no args constructor, and the builder annotation as well. We can make full use of Lombok because this is a DTO. And now we can start specifying some instance variables. What information do we want to expose for our post? So we're going to want the ID, which is of UUID type. We're going to want a string title, a string content, and we're also going to want a reference to the author. So let's just put a to-do in there, author. We're also going to want a reference to the category. So we'll say private category DTO, and we'll call that one category. We're also going to want a reference to the tags. So we'll say private set of tag, and we use the name tag response for the DTO for tags. So we'll say tag response, and we'll call this one tags. Let's just import set. And then we'll have a private integer, and we'll call that one reading time. And we'll also expose the local date time for created at, private local date time for updated at, and then the post status as well. So let's deal with the author next. And for that, we're going to have to create a DTO to represent the author, which of course is a user entity in our database. So we don't want to expose the full user. So let's open up the project here. We'll go to the DTOs package and we'll create a new Java class, and we'll call this one author DTO. Let's expand this. Now as a DTO, we're going to use the data, all args constructor, no args constructor, and we'll have the builder as well. And we'll say private UUID, and we want to expose the ID, and we'll also want to expose the name of the author. And this will allow us to display author information alongside our post. So back to Post DTO, we can now specify a private author DTO, which we will call author. However, looking at this, the only thing that seems to be inconsistent in naming is this tag response name. So I'm going to rename this, and we'll call that one tag DTO. Select all, and then we'll go OK. And in that way, we have a representation of our post now, a DTO that we can use in our presentation layer. So if we go back to Post Controller, we can now specify Post DTO as the type that's being returned. And of course, we'll need to implement a service for this, but let's just fill in the rest of this method to begin with. So we'll call this method getAllPosts. And this method is going to have two request params. So the first one, request param, we'll say it's optional, so required equals false. And it will be a UUID, and we'll call this one category ID. And the second one will be very similar, except for instead of category ID, we'll say tag ID. And these two query parameters will allow us to filter posts based on the category and the tag, or both. Let's just scroll down a bit. So at this point, we need to implement our service. So let's go ahead and do that. So let's open up the project on the left here. Let's scroll down to our services package. And in here, we're going to create a new interface. And we'll call this one post service. And that will be an interface. Let's expand that. And let's define a method which will allow us to return all of the posts which match the category ID or the tag ID as optional parameters. Remembering, of course, that we're only going to return published post to the user. So we're going to return a list of post. This could be pagination in future if we chose to. Let's just import this. But a list will do for the moment. And we'll call this method getAllPosts. And we'll pass in a UUID, which is the category ID, and a second UUID, and we'll call that one tag ID. And that should do for the moment. So let's open up our project on the left here, and then we'll create a new implementation class, and we'll call this one post service impl. Let's expand that. And we'll say that implements post service. We'll hover over the red squiggle. We'll go implement methods. Okay. And we have our method stub. Before we go any further, let's make sure we put the @service annotation on the top of this service. And now we can start implementing our getAllPosts method. Now we're going to need to interact with the database for this one. So let's declare a instance variable of private final post repository. Call that post repository. And then we'll put the required R's constructor on the top there. And that will create a constructor for us, which means our post repository is injected and available to use. As we're also dealing with categories and tags, it would make sense for us to inject those services as well so we could use them in our implementation. So we'll say private final category service, which we'll call category service, private final tag service, which we'll call tag service. And now we can get to implementing our getAllPosts method. So the first thing that we want to do is check the values of category ID and tag ID. These are optional, so they could be null. So let's check the case where they're both provided. They're both not null. So we'll say if category ID is not null and tag ID is not null, then we want to return all published posts that match both the category ID and the tag ID. So in this case, we only want to return published posts that match both the category ID and the tag ID. And we want to make sure that the proper exceptions are thrown with the proper values in the case that either the category or the tag doesn't exist. So to do this, we'll rely on the services. So first we want to get the category by its ID. So if we take a look at the category service here, we have list categories, create category, delete category, but we don't have get category by ID. So let's implement a method for that. So this one will return a category. We'll call this get category by ID, and then we'll pass in the UUID ID. And if we go down to the implementation, hover over here, then we'll go implement methods, get category by ID. We can then implement get category by ID. So we're not going to return an optional category in this instance. We are going to throw that entity not found exception. So we'll delete return null, and we'll say category repository dot find by ID, passing in the ID argument. And then we'll say or else throw, and we'll throw a new entity not found exception. And we'll say category not found with ID. And then we'll say ID semicolon. And let's return this. Now, before we go any further, let's make sure the entity not found exception is handled correctly. So let's go up to project. Let's go to our error controller. Let's double click this. And we'll add another block to the end here. And we'll just swap out entity not found exception in all the cases that the exception class is specified. So handle entity not found exception, entity not found exception. And we're going to return a not found. We'll pass through the message from the exception. And then we'll return that with not found. And this will return the correct error message for when the category or the tag doesn't exist, because we'll be throwing an entity not found exception in both cases. So let's close error controller and let's go back to our post service impl. So now we can say category service dot get category by ID, passing in the category ID. I'm going to assign that to a variable, which we will call category. And now let's do the same for tag. So let's take a look at the tag service. We don't have a get tag by ID, so let's add one. Tag, get tag by ID, passing in the UUID, ID for tag. Implementation class, hover over, implement methods, OK. And now we can do a very similar implementation. Tag repository dot find by ID, passing in the ID, or else throw new entity not found exception. Let's put that on a new line. We'll say tag with, and we'll say tag not found with ID, ID. And because we're already handling that entity not found exception, we don't need to do anything further for this one. Back to the post service impl, and now we can get our tag. Tag equals tag service dot get tag by ID, passing in the tag ID. Let's just import tag. Now bear in mind that exception will only be thrown in the case that something has gone wrong on the UI or somebody is trying to hit the REST API directly, because the UI is only going to display categories and tags that exist, which helps influence why an exception was used in this case. So now that we're certain both the category and the tag exists in the database, we can now go about filtering all posts by that category and tag. We've got the objects here, so we'll use them. So let's just take a look in post repository. So to the post repository, I'm going to add a new method here. It's going to return a list of posts. Let's just import list. And I'm going to call this one find all by status and category and tags containing. And to that, we're going to pass a post status object, which we'll call status, category object, which we'll call category, and a tag object that we'll call tag. Remembering that we're specifying the post status also because we only want to return published posts. And we're using this naming convention because Spring Data JPA is going to work out the implementation for us because we follow this very particular naming convention, the details of which can be found in the Spring Data JPA docs. So if we copy this, we can now use this in our post service impl class, post repository dot the method that we've just created. And we'll pass in post status dot published. I only want to return published post. And we're going to pass in the category object and the tag object as well. And we'll return the results of this repository method call. Now we are making multiple calls to the database in this function, but we're not writing anything. So I am going to add the @transactional annotation to the top here, but I am going to say read only equals true. That's something that's available when you import from the Spring Framework transactional annotation rather than the Jakarta one. So we're covering the case that both the category ID and tag ID is specified. What about when only the category ID is specified? If category ID does not equal null, providing we'll only get to this if statement if the tag ID is null. So if category ID does not equal null, then we'll first do the check to make sure the category exists, throwing the exception otherwise, which will be exactly the same method call up here actually. Let's copy that. And now we'll need to make a call to our post repository. Let's add a new method for this one. Be very similar to our last. Return a list of post, and we'll call this one find all by status and category, specifying the post status of status and the category. Go back to the post service impl, and now we'll call post repository dot find all by status and category, passing in the post status of published. We're only returning published posts, and then we'll pass in the category that we've retrieved from the database, and we'll return this. And there we go. Of course, we've also got the case when the tag ID is provided and category ID is null. So we'll say if tag ID does not equal null, we'll attempt to get the tag from the database, which will actually be this line here. So either that will throw an exception or retrieve the tag if it exists. And if it does exist, we can use it to query our post repository. And for that, we're going to need a new method, which will return a list of posts, find all by status and tags containing, and then we'll pass in post status of post status, and then the tag. And that will return a list of posts. So if we go back to post service impl, we'll now call return post repository dot the method that we've just added, passing in the post status of published and the tag that we've just retrieved from the database. So we've covered the case where both the category ID and the tag ID is provided. So we make sure that both the category and the tag exist, and then we filter all posts, all published posts by the category and tag. Then we have the case where the tag ID is null and the category ID is provided. And then the opposite of that, where the tag ID is provided and the category ID is null. But what happens when both the category and the tag ID are null? Well, we simply want to return all of the published posts. And we can do that by adding a new method to our post repository, which will be the simplest of the bunch so far, returning a list of post, and we'll call this one find all by status, passing in the post status. And now if we go back to post service impl, we'll say return post repository dot find all by status, specifying post status dot published. We have a post status rather than post service, and we'll call that one status. And it looks like we've used post status rather than status there, so let's change that. So we go back to post service impl. That now looks to be compiling. So now that we have our get all posts service method available, let's go all the way back to our post controller here. And now we'll want to get hold of our post service. So private final post service, which we'll call post service. And now we can use it inside of our get all posts method. So we'll say post service dot get all posts, passing in the category ID, which may be null, and the tag ID, which also may be null. And we'll assign that to a variable, which we'll call posts. Of course, we'll now want to convert our list of posts to a list of post DTO. And for that, we'll need to use a mapper. So let's take a look at the project here. Go to our mappers directory, and then we'll need to create a new mapper. So let's create a new class, and we'll call this one post mapper, making it an interface. Let's expand this. So we'll use the @mapper annotation to the top here, specifying the component model as Spring, the unmapped target policy, reporting policy.ignore, and now we'll specify a method which returns a post DTO. We'll call this one toDTO, which accepts a post entity, which we'll call post. Of course, inside of our post, we have our user, so our author, the category, and the tags. So we'll add some mapping annotations to the top here, which says the target, which in this case is author. The source is going to be author. We'll do that for the category, and we'll do that for the tags as well. So we now have our toDTO post mapper that we can use. So we go back to the post controller, private final post mapper, and now we can say posts dot, and we'll do stream map, and then we'll say post mapper dot toDTO, passing in the post, which we can optimize on, and then we'll collect to a list, and we'll assign that to a variable, which we'll call post DTOs. And now that we have a list of post DTOs, all that we're left to do is return a response entity with a HTTP 200 of our post DTOs. And with that, our get all post endpoint should be working. So let's try it out. Let's start or restart our blog application. And that seems to be working. So let's go ahead and try this out. The easiest way to do that is just to go to the front end. So let's head straight there. So here we are back in our front end. And if we take a look at our network panel here, we're making a call to posts, a get call, API v1 posts, that's returning a HTTP 200. If we look at the response, we can see here that we simply have an empty list, which makes sense because we haven't created any posts yet. So it looks like our list post endpoint is working as expected. Building on our post listing functionality from the previous lesson, we'll now implement an endpoint for writers to view their draft posts. This feature will enable content creators to work on draft works whilst only exposing published works to the public. So here we are back in our IDE. So let's head over to the post controller. Let's expand this and let's get to work on our draft post endpoint. So for this, we're going to say get mapping, where the path of that is going to be /drafts. So it'll be API v1 post / drafts. And that's going to be a public method returning a response entity containing a list of post DTO. Not too dissimilar from our get all posts endpoint. But we're going to call this one get drafts. Now, although we're not going to be implementing any proper authorization inside of this application, what we can do is get hold of the request attribute that we are setting in the JWT filter. So request attribute, which represents the user ID. And then we can use that to filter the drafts based on the logged in user. So although there's not any authorization rules to say this user can't view another user's draft posts, by default, this endpoint would filter draft posts to only the logged in user. Of course, there's nothing to stop you from extending this functionality and implementing proper authorization on top of this implementation. So let's get the logged in user to begin with. So let's open up our project here, take a look at our services. And we don't yet have a user service. So let's go ahead and create one of those. New Java class, user service, and this will be an interface. And let's expand this. And to this service, we're going to add a method, which returns a user, which we will call get user by ID. And this will take a UUID, which we will call ID, and that represents the ID of the user. So with the user service interface created, let's expand import here, create a new Java class, and we'll call this one user service import. Let's expand this. And then we'll say this implements user service, hover over the red squiggle, implement methods, OK. And now we can get to work implementing our get user by ID. But before we do, at service on the top there, and we'll also say required arts constructor to allow us to inject collaborators. Now, of course, we're going to be interacting with the database. So we'll say private final user repository, user repository. Now, the implementation of this is largely just going to be a pass-through. So we'll say user repository dot find by ID. We'll pass in the ID from the arguments, return this. And to keep things consistent with our other implementations and to rely on our exception handling, we'll say or else throw a new entity not found exception, and we'll say user not found with ID. So you now have a means of getting a user from the database via its ID. So we go back to our post controller, inject our user service, private final user service. We can now get hold of our user service dot get user by ID, user ID. And we'll assign that to a variable, which we'll call logged in user. Now let's implement a method to get the draft post for the user. So inside of our post service here, let's implement a method which will return a list of posts, which we'll call get draft posts, and it will accept a single argument, which will be a user. And let's import user, returning all draft posts for this user. So let's go down to the implementation, hover over here, go implement methods, OK. And now we can get to work on implementing this method. So let's say post repository dot, and we'll need to add a new method to our post repository. So let's head over to there. And let's have this method return a list of posts, and we'll call it find all by author and status. And we'll pass in a user object, which we'll call author, and a post status, which we'll call status. And again, because of the naming convention, we won't have to provide an implementation for this, but we can use it inside of our post service. So we'll say find all by author and status. We'll pass in the user from the argument there, and our post status will be draft, because we're only returning draft posts in this instance. So with that done, we have a get draft post method that we can use in our post controller. So let's say post service dot get draft posts, passing in the logged in user, and that should return a list of draft posts, which of course we can then call draft posts dot stream dot map, and then we can call post mapper to DTO, and then we'll call to list. And that will give us a list of post DTOs, and we can then return response entity dot OK with the post DTOs. And with that, we should have a working get drafts endpoint. Now, before we restart our application, let's just take a look at the Spring Security configuration here. And let's expand this. Let's take a look at our security filter chain. So taking a look at this configuration, the first request matcher to match our drafts endpoint will be this one here, which specifies permit all. And we don't want the drafts endpoint to be permit all. We want it to be authenticated. So I'm going to add a new request matcher before this one here. I'm going to specify drafts, API v1 post drafts, so an exact match, and we're going to say authenticated. And that's going to mean that a user has to be authenticated in order to hit the drafts endpoint. Remembering when you're using this setup, it's the first match that wins. So even though this will match our drafts endpoint, because we've specified this line prior, it means this one will match, and therefore the drafts endpoint will require authentication. So let's restart our application and try out our new endpoint. Okay, that's the application restarted successfully. So let's head over to our front end and try this out. So if we clear our networks panel and then click on draft posts, we can see that requests are coming back HTTP 200 from our drafts endpoint. The front end is passing some additional query parameters in, which is to do with pagination. However, they'll just simply be ignored by our backend. The main thing is that we're calling this endpoint here. And if we go to response, we can see we have an empty list returned. Now, we've yet to confirm that the post structure is being returned correctly. And for that, we'll need to create some posts. So let's focus on that in the next lesson. However, before we do, let's just make sure that we can't hit this drafts endpoint when we're not authenticated. So I'm going to copy this endpoint here. I'm then going to open up a new incognito window. And then I'm going to paste that URL in. Perfect. So HTTP 403. You don't have authorization to view this page, and that's because we're not providing any authentication information when we're trying to access the drafts endpoint. So with that out of the way, let's get to implementing our create post endpoint. So building on our listing post functionality for both our published post and our draft posts, let's now implement the ability for authenticated users to create new blog posts. This endpoint will enable writers to compose and save both draft and published content with proper categorization and tagging. So here we are back in our IDE. So let's head over to the post controller. Let's expand this and let's get to work on our create post endpoint. So this one is going to be a post mapping. We don't need to specify anything additional in the path. We're just going to use the default path API v1 posts. This will be a public method, returning a response entity, which wraps a post DTO, so the post that was created. And we'll call this method create post. Now, to this method, we're going to have to pass a representation of the post to create. So let's go ahead and create a DTO for that. Let's head to the DTOs package here, and we're going to create a new class, and we'll call this one create post request DTO. And let's expand this. So as a DTO, we can make full use of Lombok, so at data, all R's constructor, no R's constructor, at builder. And now we can specify the information that we'll need to create a post. And we can do this with validation annotations as well. So we'll first need the post title, which we'll use the string type for, title. And now we can start adding validation annotations. So we want to make sure that the title is actually provided and it's not an empty string. So to the top here, we'll add not blank, with the message title is required. We'll also want to make sure that the title isn't too short and it's not too long. So let's add the @size annotation to this instance variable and a message of title must be between min and max characters. And that should do it for the title. Now let's handle the content, which we'll represent with a string and we'll call content. Now again, we want to make sure that this is not blank. So we'll add the not blank annotation to the top here. And we'll also add the @size annotation. Of course, content's going to be a lot larger, potentially, than title. So a minimum of 10 characters and a maximum of 50,000. With the message, the content must be between min and max characters. Now we'll also want to know the category to which this post belongs. And we can represent that with the category ID. So we'll say private UUID. And we'll call this one category ID. And of course, we'll want to make sure that category ID is actually provided, not null. So we'll add the not null annotation there. Now we'll also want to know any tags this post is associated with. So we'll do private set of UUIDs, which represents the ID of the tag. And we'll call this one tag IDs hash set for the default value. Now, as we are using the Lombok builder, we'll also put the builder default on the top there. However, we'll want to specify a maximum number of 10 tags per post. So we're going to add the @size annotation here with a max of 10, maximum of 10 tags are allowed. Of course, we'll also want to know the status of this post. Are we creating a draft post or a published post? So we'll add a private post status, which we'll just call status. And again, we'll want to make sure this is not null. So we're going to add the not null annotation to the top here with the message status is required. So we now have a DTO which represents all the information we need to create a post. So let's go ahead and use this over in our post controller. So we'll add the @request body annotation because of course there'll be a JSON representation posted to this endpoint, request body, create post request DTO, which we'll import, and we'll call this one create post request DTO. Now, as only logged in users can create the post, we'll also get hold of the user that's logged in as well, which we can do by grabbing hold of the user ID, and we'll use the user service just like we've done when listing drafts. So we have our logged in user to work with as well. Let's just reformat that slightly. Okay. Now we don't want to be passing a DTO to our service layer. So we need to have a representation of the create post information that our service layer can use. So let's go ahead and create one of those. And that will allow us to create our create post method in our service layer. So we won't put this in DTOs because it's not a DTO, and we won't put it in entities because it's not an entity either. So we're going to create a new Java class in domain, and we'll call this one create post request. And let's expand this. Now to speed things along, I'll implement this and then talk you through it because we've just gone through all of the instance variables in the DTO, and this will be exactly the same, at least for the initial implementation. So even though we're using this class in our service layer, we're able to make full use of Lombok because we're not adding any JPA annotations to this class. And you'll notice the title, content, category ID, tag IDs, and status are exactly the same instance variables that we have over on our DTO. So now that we have our create post DTO and also a class that we can use in our service layer, let's just make sure we can map between the two. So let's go to project and let's go to our post mapper, expand this, and we'll add a new method on here, which will return a create post request. And we'll call this one to create post request. And it will accept a create post request DTO, which we'll just call DTO. And that's all we need to do for the mapper. Map struct can work out everything else. So back in our post controller now, we're able to take our create post request DTO and then use the post mapper to convert that into an object that we can pass into our service layer, which will assign to a variable called create post request. So let's now implement a method in our service layer to create a post. So let's go over to our post service and we'll add a new method here, which returns a post entity, the post that was created, and we'll call this one create post. And this method will need both the logged in user, which we'll use the type user entity for, and a create post request, not the DTO, but the one we can use in the service layer, and we'll call that one create post request. So with that done, let's go to the implementing class, hover over the squiggle, implement methods, click OK. And now we can get to implementing this method. So let's create a new post, and we'll call this one new post equals new post. And we can set the title on this post. So new post dot set title from the create post request dot get title. And let's also set the content, new post dot set content, create post request, get content. We'll also do the same for the status, set status, create post request dot get status. We'll also set the author, and we can do that from the logged in user. So new post dot set author, and that will be the logged in user. The system won't support the ability to create a post as a different user. Of course, you can always extend it to do so, but we'll just use the logged in user as the author. New post dot set reading time. Now we'll also want to set the reading time on the post. We'll calculate that when we save it, and that will save us from having to recalculate it every single time we get the post from the database. So let's just create a very simple private method to do this estimation for us. Of course, you can make this as detailed as you like, but we'll just go with a very simple implementation to begin with. So we'll call this method calculate reading time, and it will accept the string of content, returning an integer. So if the content is null to begin with, or if the content is empty, then we'll return 0 minutes because it's null or empty. It will take no time at all to read. Now let's just get the word count from the content. So we'll say content dot, and we'll trim it to begin with. And then we're going to split, and we'll use a regex for this, // s plus. And then we'll call dot length on that. And that should give us a very rudimentary word count. So now that we have the word count of the content, we simply need to determine what an average words per minute is, and then that will give us a number of minutes it would take to read this content. Now let's just say 200 words per minute is what we're going to use. So let's just create a variable for that. Private, static, final, int, and we'll call this one words per minute. And we'll set a value of 200 for that, which we can then use in our calculations. So we'll say word count divided by words per minute, but we'll want to cast word count to a double. And then we'll do a math.ceil on that as well. And then we'll return that, but we'll cast it back to an int. Again, very rudimentary implementation to get a rough reading time. So we can now use this calculate reading time inside of our create post implementation, passing in the create post request.get content. Now let's assign the specified category to our post. So we're going to use the category service for that. Let's just see if we've got that available. We do, wonderful. So let's call category service dot get category by ID, create post request dot get category ID. Again, remembering that will throw an exception if the category doesn't exist, and that's handled for us already. So that will give us our category. So we'll say new post dot set category. And now let's also look up the tags. So let's get hold of those tags. Create post request dot get tag IDs, and that's our tag IDs. Now, if we take a look at our tag service, see what methods we have available, we have get tag by ID, but we don't yet have a get tag by IDs. So let's create one of those. So we'll just return a list of tag, and we'll call this one get tag by IDs, plural. And we'll pass in a set of UUID, and then that will be called IDs. If we go down to the tag service implementation, hover over here, implement those methods, click OK. And for the implementation, we're going to call the tag repository dot find all by ID, passing in the iterable, which of course is our set. And then that will give us a variable, which we'll call found tags. Now what we'll do is rather than just return them, we'll say if found tags dot size does not equal IDs dot size, then we'll throw a new entity not found exception. And to keep it simple, we'll just say not all specified tag IDs exist. And then we'll return the found tags if we in fact find that they all do exist. So now that we have our get tag by IDs, let's go back to our post service, import here, and we're now able to use this method. So we'll say tag service dot get tag by IDs, passing in our tag IDs. We'll assign that to a variable, which we'll simply call tags. And now we can say new post dot set tags to the provided tags. But of course, that will need to be a set. So we'll see new hash set, passing in the list there. There we go. So we should have set all of the values, including the category and the tags, and we set the reading time as well. So we'll now say return post repository dot save, and we'll pass in our new post, semicolon at the end. And because we're making multiple calls to the database, we'll put the @transactional annotation on the top of this method. So now that we have our create post method available to use, let's go over to our post controller, and we can now call post service dot create post, passing in the logged in user and the create post request. And we'll assign this to a variable, which we'll call created post. And then we'll use our post mapper dot to DTO, passing in the created post. We'll assign that to a variable called created post DTO, which we can then return in a new response entity, created post DTO, and we'll use the HTTP status code of created in this instance. And with that, we should have the initial implementation of our create post endpoint ready to use. So let's restart our backend. Okay, that's the application we started successfully. So let's head over to our front end and try this out. So here we are back in our front end and we're all logged in. Before we can create a post, we must create at least one category. So let's go ahead and do that first. Over to categories, add category, and we'll call this category test. And we'll go add. Great, and that's the category created. Let's create some tags while we're here. And we'll call this one test tag. And let's click on add tags. So we have both a test tag and a category to work with. So let's go to new post and we'll add a title of test title. And now we can add some content. This is some test content. Let's hope we meet the character requirements. And if we scroll down, we can select our category, test, our tag, test tag. And initially we'll put this in draft status, I think. So let's just scroll up to make sure the create post button is available. Let's clear our network panel and let's click on create post. Okay, so let's just take a look. We've got a HTTP 201. Let's take a look at the payload. There's our title. There's our category ID, the content, the draft status, the tag IDs, and the title, test title. And it looks like we've got a response back with an ID, the title, the content's in there, the author object is in there as well. There's our category. There's our tag. We have a reading time of 1 minute for this. And then we have the created, updated. However, post status is returning null, and that might be something that we need to look into. Let's just see if we can see this on our draft posts. Okay, so the status being returned as null looks like a mapper issue, so we may have to fix that later. But it looks like the logic for returning draft posts is working, because here is our test post. If we go home, we can see that although we have our test tag here, we don't see any posts because we've created a draft post. Whilst we're here, let's see if our list post endpoint works. Let's create another new post. We'll call this one test post 2. For the content, let's hope this also meets the character requirement. Let's scroll down. Oh, typo. Let's fix that. Now let's scroll down. Category, test, test tag, status, published this time. And then we'll clear our network panel, click on create post. And we're back on the home page and we see test post 2. So it looks like both our list draft posts and our list publish post endpoints are working in addition to our create post endpoint. So now that we're able to create posts, let's implement the ability to update posts. This endpoint will enable content creators to modify post content, change categories and tags, and toggle between draft and published states. So here we are back in our IDE. So let's head over to the post controller. Let's expand this and let's go about implementing the update endpoint. So we're going to use a put mapping for this. And the path is going to specify the ID of the post. So we'll say public, returning a response entity, which will be the post DTO, so representing the updated post. And we'll call this one update post. So let's first get hold of that path variable, UUID, and we'll call that one ID. Now we'll need some way of representing the update post request. So we'll need to create a DTO for that. So let's open up projects here. Let's go to our DTOs package and we'll create a new Java class and we'll call this one update post request DTO. And let's expand this. Again, as this is a DTO, we can use lombok at data, all ours constructor, no ours constructor, builder, and then we can specify the instance variables that we would like to be able to update. Perhaps with the exception of the first one, which is going to be the ID, because we need to know the ID of the post that we'd like to update. It needs to be an existing post. And we'll put some validation annotations on the top here as well. So not null to make sure that we do get an ID provided. Now we'll want to specify the title. We want to be able to update the title, private string title. And just like on our create DTO, we're going to specify not blank. and then a specified size. The endpoint that we're creating is a full update endpoint, so all information is going to be provided each time, even if it's not updated. So we're going to add not blank and then a size on the title to make sure that it's provided and is valid. And now we'll want the content, private string content. And again, we'll add some annotations to the top here. We'll have not blank to make sure that the content is provided, and we'll have size to make sure that the content is in the specific character limits. And then we'll want to know the category to which this post belongs, UUID, and we'll call that one category ID. Again, we'll add a validation annotation to the top here of not null to make sure that we do actually get a category ID. And now we'll specify a private set of UUIDs, and this will represent the tag IDs. There we go, and let's import set. And we'll also put the validation annotation of a size on the top here, and because we're using Lombok, we'll make that the builder default as well. And then we'll also want a private post status to represent the post status. And we'll put the not null annotation on the top here to make sure that it is provided. So very similar to our create. Let's just see what this red squiggle is. Ah, yes, we forgot to initialize tag IDs to be a new hash set. There we go. And with that, we should have a update post request DTO that we can use. So back over to the post controller, we can now specify a request body, update post request DTO, and we'll call that one update request post DTO. Now, in order to use those validation annotations, we need to put the @valid annotation in front. And come to think about it, let's just take a look at our create endpoint. We've missed it off there, so let's add it in there too. Okay, perfect. So we now have a valid update post request DTO that we can use. But of course, we can't pass a DTO to our service layer, so let's create an object that we can use in our service layer. Let's minimize DTOs, and let's create a new Java class in domain, and we'll call this one update post request. So just like the pattern we followed for our create post endpoint, it will be the same for the update post endpoint. This will be practically identical to our update post request DTO, at least initially. So I'm going to just implement this to save on some time. So here we have our update post request, full Lombok annotations, ID, title, content, category ID, tag IDs, and status. So all of the fields that can be updated on our post, and all are required because this is a full update endpoint. So we have an update post request DTO and an update post request. We'll just need a mapper to go between them. So let's go to post mapper, expand this, and then we'll return an update post request, and we'll say to update post request, passing in an update post request DTO, which we'll call DTO. So we go back to our post controller now. So let's now use our post mapper to convert our update post request DTO to an update post request, an object that we can pass to our service layer. And now we're able to create our update post method on our post service. So we'll head to the post service and we'll specify a new method here. It will return the post that was updated, and we'll call this one update post. And it will take the ID of the post update and an update post request, which we'll call update post request. Now you might be wondering why we're not specifying the user in this case. Well, we needed the user when we created the post. We're not offering the ability to update the user. Now your next question might be, well, why not accept the user and then use that to make sure that the user is only trying to update their own post? And you would absolutely be right. But that's where the scope of our implementation ends. After that point, we start implementing authorization, and we're not going to do that for this project. So we're not going to accept the user for our update post method because we're not looking to update the user to which the post belongs. Of course, you're more than welcome to extend that and implement that if you choose to. So now that we have our update post method declared, let's now go to our post service impl, hover over here and go implement methods and click on OK. And now we can start implementing. So we're going to need to get our post by ID. Let's see if we have a method to do so. We have get all posts. We have get draft post, create post, but we don't have a means of getting a post by an ID. So we'll call straight through to the repository, post repository dot find by ID, passing in the ID of the post. And that will return an optional. So we're going to say or else throw a new entity not found exception, and we'll put that on a new line, and we'll say post does not exist with ID. Let's assign that to a variable, which we'll call existing post. Now, because this is a full update endpoint, we'll simply take all of the information from our update post request and set it on the existing post. So existing post dot set title will be update post request dot get title. Same for the content, existing post dot get content equals update post request dot get content. Status, existing post dot set status equals update post request dot get status. Oh, I've called get content there when I should have called set content. Okay, so we set status. Now let's set the reading time, existing post dot set reading time, and we'll just recalculate the reading time from the content. So update post request, get content, which you might as well assign to a variable, replacing two instances, and we'll call that one post content. Now let's update the category, but only if it's changed. So we'll get the update post request dot get category ID, and we'll assign that to a variable, which we'll call update post request category ID. And we'll say if the existing post dot get category dot get ID equals update post request category ID. However, we're going to say if it does not equal. So that's to say if the update post request provides a UUID or a different category to what we currently have set, then let's use the category service to get that category by ID, update post request category. We'll assign that to a variable, which we'll call new category. And then we'll say existing post dot set category new category. Now let's do the same for the tags. So we'll say existing post dot get tags, and then we'll call stream.map, and then we'll extract the tag ID. There we go. And then we're going to collect that to a set. And we'll assign this to a variable, and we'll say existing tag IDs. And then we'll say update post request dot get tag IDs. We'll assign that to a variable as well. And then we'll say if existing tag IDs equals update post request tag IDs, but if it doesn't equal, then we'll go ahead and update it. So we'll say tag service dot get tag by IDs, passing in the update post request tag IDs, and then that will return the new tags. And then we'll simply say existing post dot set tags new tags. But of course, it will need to be a set, so it's called hash set, passing in the new tags list. And with that done, we can then call post repository dot save, passing in the existing post, which of course has been updated. And then we'll return that at the end. And of course, we'll put the @transactional annotation on top of this method because we're making multiple calls to the database. So we retrieve the existing post from the database. We then go about setting new values on it, taking from the update post request, updating the categories if the category has been updated, and also updating the tags if the tags have been updated. We do this check just to make sure we're not making unnecessary database calls. Just a very easy way to optimize. So with our update post method implemented, let's head back to our post controller. And then inside of our update post method, we can use our new update post method. So let's say post service dot update post, passing in the ID of the post and the update post request DTO. That will give us our updated post. Of course, we're not passing in the DTO, but the actual object that we can use in our service layer. We have our updated post, so let's convert that to a post DTO. So post mapper to DTO, passing in the updated post to get our updated post DTO, and then we can return response entity .ok with our updated post DTO. And with that, we should have our update post endpoint available to use. So let's restart our backend. So that's our backend restarted successfully. So let's head over to our front end and try this out. So here we are back in our front end. So let's head over to our draft post to begin with. And if we click on our post here, we get an error. And that's because, of course, we haven't implemented our get post endpoint. So let's implement that now, and then we'll come back to fully test this. In order to be able to update our post, we must be able to retrieve a post by its ID. So let's implement the get post endpoint. So here we are back in our IDE. So let's head over to our post controller. Let's expand this and let's add a new endpoint. This will be a get mapping where the path specifies the ID. And this will be a public method returning a response entity of post DTO. And we'll call this one get post. This will take the path variable UUID ID, and then we can use that ID in order to retrieve the post from the database. However, in order to do that, we'll need to add a new method to our post service. So let's head there now. We'll add this method to the top there. It will return a post, throwing an exception if the post doesn't exist. And we'll call this one get post, specifying the UUID ID. So we go to the implementation, hover over here, go implement methods, okay. And we can now implement this method. So we'll call post repository dot find by ID, passing in the ID, or else throw, in the case that we get an optional empty, a new entity not found exception, put that on a new line, and we'll say post does not exist with ID, and we'll return that. And now we can use our get post in our post controller. We'll call post service dot get post, passing in the ID from the arguments, and we'll assign that to a variable called post. And then we can use our post mapper dot to DTO, passing in the post there. We'll assign that to a variable called post DTO. And now we can return response entity dot OK with our post DTO. Great. So let's restart our backend. So that's our backend restarted successfully. So let's head over to our front end and try out our get post endpoint and also our update post endpoint. So here we are back in our front end. So let's head over to draft posts and let's click on the first post here. Great. Okay. So if we take a look in our networks panel, we can see the call to get posts is returning HTTP 200 and the post object. So let's click on edit. And now let's change this to be updated test title, updated content, and we'll keep the category as is and the tags as is, but let's change it from draft to be published. And before we click on update post, let's clear our network panel, click on update post. We're at HTTP 500. Let's take a look in our stack trace to see why. Scroll up here. We have a validation failure, and it's because the post status is null. So it looks like we do need to fix that post status mapping after all. So let's do that now. So on our post, we have a variable status. Now, if we take a look at the post DTO, expand this, I see we've called it post status. So if we change this to be status and then start or restart our application, great. Okay, so that's our application started up once more. So let's head back to our front end. Let's click on test post 2. And if we take a look at the get post call and scroll down to the bottom, great. So status is now being populated. That's perfect. So if we now click on edit, we'll go update, update, and let's scroll down to update post. Okay. Looks like we're still getting an error of 500. So let's now go back to our backend. Let's look at the stack trace. Validation failed because the post status field is null on the update post request DTO. So there may be a mismatch on the status name as well. Let's just take a look. So it seems to be working for the create, but not for the update. So if we just take a look at the update post request, we're using the variable name status. Now, if we take a look at the update post request DTO, expand this, we're using post status. We change that to be status, and then start or restart our application. That's our application restarted successfully. So let's head back to our front end. So draft posts, let's click on our test post here. Let's click on edit. Let's update the title, updated. Let's update the content, updated. And let's click on update post. Before we do, let's just clear the networks panel. Update post. Okay, so we're back on the home page and we can see an updated post, updated test post 2, updated content. If we take a look for the update post, there it is. So there's our put. We can see the payload with the updated information and we get a successful response back with the updated values. So in summary then, the errors that we were seeing were to do with the mappings. Because mapstruct, let's pull this down, and go to the post mapper, let's expand this. Because mapstruct by default would look to match the target instance variable name and source instance variable name, assuming they're the same. And because we used a slightly different name in some of our classes, it was unable to match that up, meaning that we had nulls, and then our validation did its job and was returning exceptions. So now that we have all of the correct instance variable names, everything seems to be matching up and validation passes. So somewhat of an accident, but demonstrates both the validation and the mapstruct behaviors. So now that we're able to create and update posts, let's add the ability to delete posts. So here we are back in our IDE. Let's head over to the post controller. Let's expand this and let's add a delete mapping, specifying a ID. And this endpoint will be public, returning a response entity of void, because it won't have a response body. And we'll call this one delete post. And then we'll specify the path variable, UUID, ID. So now that we have the ID of the post that we want to delete, we'll need to create a new method on our post service to delete posts. So let's head over to our post service and let's add a new method, a void method this time, and we'll call this one delete post. And it will take UUID, which is the ID of the post to delete. Let's go down to the implementation, hover over here, implement methods, we'll click on OK, and now we can implement this method. So now we have a decision to make, and the decision is, what do we do when the post doesn't exist? One option is that we don't do anything. Because the post doesn't exist, delete post has successfully done its job because the post doesn't exist. However, because of the implementation elsewhere in the application, I think it would make sense to throw an exception just to inform the user that the post doesn't exist. And I think that's what we'll do in this instance. So we're going to use getPost, passing in the ID to get the existing post. Remember that getPost, we go to it, we'll throw an entity not found exception, which will be handled by our exception handler. So we'll check to see if the post exists. If not, return the correct exception. And now we can delete the post. So we'll say post repository dot delete, passing in the post entity. And with that, we've implemented our delete post method. So let's go back to our post controller, scroll down here, and then we'll call post service dot delete post, passing in the ID from the path. And then we're going to return a response entity dot no content dot build. And with that, we've implemented our delete post endpoint. So let's restart our application. That's our application restarted. So let's head back to our front end. So here we are back in our front end and we have two posts. So let's select the one that we updated. Let's clear our networks panel and let's click on the delete button here. Let's click on OK. Okay, we're back on the home screen and we only have a single post displayed. Let's take a look at this one. A delete call returned a HTTP 204 no content, and it looks like the delete has worked successfully. So we now have our first working implementation of our application. Let's just do a review and discuss where we could go from here and some thoughts. So here we are back in our application. Let's just try out some things to make sure that we're working, and then we can discuss where we can go from here. So let's create a new category to begin with. I'm going to call this one, we'll call this one category 2. I'll click on add. So we now have two categories. If we delete that, we can delete that fine, great. So category 2, we can add it back. So categories are looking good. So we've got a test tag here. Let's go with test tag 2, test tag 3, test tag 4, add tags. Great, so we can add multiple tags in there and we can delete some tags. Very good. So categories and tags looks to be working as expected. If we were to create a new post, and we'll call this one new post 3. This is some content. Select a different category this time, perhaps some different tags, and then we'll go straight to published with this, create post, as our new post 3. So if we wanted to try out filtering, perhaps we get category 2. Okay, filtering on category seems to be working as expected. Maybe on tag, test tag 3. Great. Tag filtering seems to be working too. This is part of the test category, but not category 2. Okay. So largely it looks like the application is working. Obviously, this is a first implementation, very, very basic and can be optimized in lots of different ways. So let's discuss where you could go from here. So back in our backend, The first place that you could go from here is obviously writing unit tests for this application. Other than that, if we take a look at our security, this can definitely use some additional work. You might want to enable CSRF, for example. And in our JWT implementation, we haven't implemented things like refresh tokens, which is something that you would want to do in a production environment. What we have gets you authenticated, but then keeping you authenticated with things like refresh tokens would definitely be a good place to go from here. In addition, we have implemented validation in a lot of our DTOs, using these validation annotations. We haven't necessarily handled them all that well on the front end, so that could be improved with helpful error messages. But we have seen these working and triggering when we weren't meeting the validation requirements. So they are doing their job, and that's really good. In terms of our mappers, they seem to be largely working as expected, but of course we did come up against an issue when we were implementing, which a test mapping to and from would have picked up straight away. So tests would be useful for these mappers, but they largely seem to be working as expected. The repository seems to be working, but of course there's a multitude of different ways you can optimize on queries, so that's always worth doing as well if that interests you. And then we have our service layer, which of course could benefit from optimizations, but largely seems to be working as expected, with implementations such as calculate reading time in the post service import being a nice, easy way to extend development. This is a very basic implementation. You can make this as complex and refined as you like. But with all of that said, here's our first implementation of our blog platform built using Spring Boot and Spring Security. And that wraps it up for part 3. I hope you found this truly valuable. And if you have, be sure to subscribe and hit the bell icon to be notified when the next project comes out. And in the meantime, why not check this one out?